Okay, so today we're going to do the last part of 8.5, the applications of integrals, okay? So we're going to do part 4. We're going to talk about normal probabilities, okay? So normal probabilities, actually we've discussed this briefly when we talked at the very end of honors pre-calc. We talked about normal probabilities, right? We talked about a normal distribution. In normal distribution, we talked about the 68, 95, 99.7 rule, where for one standard deviation, 2 and 3. So this would be one sigma, this is 2 sigma, this is 3 sigma out, right? So we had, so let's say that these are talking about probability distribution function. This is a probability distribution function, right? It's a PDF. It's a probability distribution function where when I take the integration from negative infinity to positive infinity, it always has to add up to 1. It always has to add up to 1, right? It has to be 1, right? You always have to be positive, okay? And that is on page 430. There's a green box there. It shows you that the integral from negative infinity to positive infinity of that distribution function has to be 1. And there we go. So if the probability associated with an interval from A to B is just you integrate from A to B. Okay? So let's do example number 5. Find the probability that a clock stops between 2 and 5. Okay, so 2 and 5, what, the probability is what? 1 in 12, right? And no, I'm sorry. So the probability distribution function is what? The probability to stop is going to be from 0 to 12. That's going to look like this, right? Isn't this what it's going to look like? Okay, right? So each part is going to be what? We're going to have 12 over 24, right? So so this is going to be what? 1 over 12, right? Because when I multiply the area under this curve has to be 1, right? So if this is 12, this is going to be 1/12, right? So the probability that it's going to stop between 2 and 5 is what? Between 2, well actually we'll say this 2 and this is 5, this guy's going to be what? It's going to be from basically, so this is going to be 3 times 1/12, right? 3 times 1/12, because this is the base is 3, this height is 12, 1/4, right? So your answer is going to be 1/4, okay? So let's go to the next definition, which is the normal probability distribution function. Now, so from here, now we're going to actually say, if this is a standard distribution with a mean of mu and a standard deviation of sigma, we're going to give you an actual definition of a normal distribution, and it's going to be sigma 2 over 1 e to the negative mu minus x squared over rho. Sigma. Is it 2 sigmas squared? No. 2 sigma squared. Okay? So this is a normal probability distribution with a mean of mu, sigma, standard deviation of sigma. Okay? So for those of you who are about to take my AP Stats class, don't worry about this. We're not going to ever get into anything like this. Okay, we will not be dealing with this. Those of you who have already taken my AP Stats class know this. Okay? So let's go back to the 68, 95, 97 rule. Okay, so let's do that one there. Example 6. Suppose a telephone helpline takes a mean of 2 minutes to answer a call. So the mean is 2 with a sigma of 0.5, is it? 0.5. Then 68% of the calls are answered between 1 plus or minus 1 sigma, right? So it would be 2 plus or minus 1 sigma. So that's going to be between 1.5 to 2.5. Okay? 95% is going to be 2 plus or minus 2 sigma. So this is what? 1, right? So it's going to be between 1 to 3. 3 sigma is going to be the same thing. So it's going to be between 0.5 to 3.5. Okay, so within here, you're going to get 95% of it. From here to here, you're going to get 99.7%. Okay, pretty simple. So when you can use the 68, 95, 99%, 99.7% rule, it's just very simple. Until you come to example number 7, where you come to a point where you can't use that. So this one here, that's what we have here. Suppose that the frozen spinach boxes marked as 10 ounces of spinach have a mean weight of 10.3 with a standard deviation of 0.2. So we have a mean weight of 10.3 with a sigma of 0.2. Okay, so let's stop and think about here first. Why would they have a mean of 10.3 if it is 10? Okay, why do you think? Well, the answer is kind of simple, really. It's because as a manufacturer, you always want to have a little bit more in there, right? You don't want to come to a situation where you say, if the mean was actually 10, right, and you say that it's a 10-pound spinach, half of those that you're going to manufacture are going to be less than what you're actually saying. Right? So that doesn't make any sense. That's no good, right? So this is giving you the little margin of error there, right, to always say that most of them are going to be greater than 10. Okay? So that's why we, even though we say it's 10, we manufacture it to 10.3. Okay? So, if that's the case, A, what percentage of all such spinach boxes can be expected to weigh between 10 and 11 ounces? So 10 and 11 ounces, so 10 is going to be how many sigmas away? 10 is going to be over here, and I'm 0.3 away, and one other sigma is 0.2, so I am actually 1.5 sigmas away on the bottom part. And the top part at 11, where am I at? 11, what am I at? So it's going to be 11 minus 10.3, so I'm 0.7 away, and divide that by 0.2, so I'm 3.5 sigmas away on this side, okay? All right, so you have to be able to calculate. So the way you would do that is you would put this in your calculator, and you would just go ahead and nint it, right? You can just go ahead and nint it. You can nint it to what? So you would nint from, put this in your f of x, and you go from 10 to 11, right? You can do that. And that's how you do that. B, what percentage could you explain, what percentage could we expect to weigh less than 10 ounces? Less than 10 ounces. So instead of going from 10 to 11, we would go what? 0 to 10, right? We go 0 to 10, right? Because it's 0 all the way up to 10, right? And then for C, what is the probability that the box weighs exactly 10%? This is a trick question. Okay, what is probably that it's exactly 10%? Okay, so it would be this guy here. What is the area of this line? So what is the area of a line? 0, right? So this would be the integral from 10 to 10, which is 0. The 0 probability might seem strange at first, but remember that we are assuming a continuous, unbroken interval of possible spinach lengths. In other words, you're going to go from 10 to 10. So when you do the integral, you're integrating from 10 to 10, and therefore it's going to be 0, right? Okay? All right, so that closes out 8.5. And now I know you're at home, but go ahead and raise your hand. Give yourself a pat on the back because we have just finished the entire year of AP Calculus. Congratulations.